One of the greatest obstacles to crafting health and wellness is identifying and controlling inflammation. It's at the core of all complex and chronic diseases, and it's the driving mechanism that underlies the most common symptoms that people like you struggle to overcome. Join us as we explore cutting-edge science and research to give you the information and tools you need to create the quality of life you want and deserve. And now, here is the host of Inflammation Nation, Dr. Stephen Noseworthy.
Hey guys, welcome back to the Inflammation Nation podcast. We're still talking about autonomous health, and based on something I said in one of my last episodes, we're going to talk about a functional hierarchy. One of the most important things to consider, when you're trying to find and fix metabolic issues on your own is that you need to understand that your body is designed with a functional hierarchy. And that means that some systems and some functions are fundamentally more important than others. Now, I've taught this concept to other doctors in functional medicine seminars for almost 2 decades now, and I can tell you that the ones who adopt this approach in assessing their own clients tend to deliver better care and get faster results than the docs who don't do that. And the last thing that I want is for you to get locked into an approach where, in trying to help yourself, you're trying anything to find something that works, but you don't have an organized or strategic way of going about that. And so we're going to have to build this functional hierarchy over the course of several episodes because there's several things to talk about and to think about. But know that random choices of supplements or diets or lifestyle changes or whatever have a very small chance of working for you. But if you have a sense of what's most important and you start prioritizing that before you do other things, then you have a much greater chance of doing something that's going to be effective and something that's practical. Now, this doesn't mean that you can't do more than one thing at a time. You certainly can. But if you have a problem that is more fundamental and important in this hierarchy, and if you don't deal with that up front, then you'll have a very difficult time with other things that you're trying to do. Now, here's an example of an approach that's likely to fail. Let's say someone has a thyroid issue, and obviously there is more than one type of thyroid problem. But let's say someone has a thyroid problem and they listen to a podcast, or maybe they download somebody's ebook, or they go on some kind of a protocol that supports the thyroid. And these are often based on taking things like selenium or ashwagandha. But what they don't know is that for the thyroid to work properly, other things have to be working first. And this entire principle of a hierarchy is very similar to our principle of root cause, right? Simply taking thyroid support supplements is a hit and miss tactic when you don't know what caused your thyroid to go off in the first place. It's very simple or very common for people with thyroid issues to have normal selenium and to take selenium and for it to do nothing for them. And ashwagandha, it serves many different functions. It's best known as what we call an adaptogen, but it could potentially play a role in a very specific type of thyroid dysfunction called an underconversion problem. And if you don't have that, then ashwagandha is probably not going to help your thyroid. It might help other things, but it's probably not going to do much for your thyroid system. Now, we all naturally understand this idea of a hierarchy when we start thinking about how people build houses, right? Nobody builds a house by constructing the roof first. That doesn't make any sense. We start with the foundation, then the walls go up, and then plumbing and electrical, and eventually we enclose the whole thing and we put up the roof and put shingles on the roof. It's a step-by-step process, right? And it ensures that as long as the foundation is strong and level, everything you build on it should be strong and level too, as long as you build those things correctly. But building a house requires that you start with the foundation. That's just step number one. Now, if you don't know what this functional hierarchy looks like, don't worry. I mean, I can't imagine that you were taught this in school. I know I wasn't, even as a healthcare professional. I didn't even learn this until I was about 12 years into clinical practice. Most doctors don't think this way. So there's no way anyone who's not a healthcare practitioner is really going to know it either. But I will tell you that when I explain this to my clients, that there is an order of importance and that we're going to evaluate the foundation of their physiology before we do anything else. And we fix what we find there before we go on to other things. Then all of a sudden they realize perhaps why other doctors and specialists who are probably good at what they do, but why these people have failed, because they're skipping steps. They're not building the foundation first. And it may also explain to people why their own self-help efforts didn't work out like they had hoped. Number one, they just weren't aware that they had to look for and fix certain things before they before they saw results in doing things that were perhaps higher or I guess lower on the hierarchy in terms of importance. So hopefully you get the idea here, but let me just repeat the core principle because I think it's worth repeating. Some systems and functions are more important than others, and they serve as the foundation of everything else. So naturally, our starting point in trying to find root cause or to find and fix problems in the foundation has to be there before we start moving up the hierarchy. Now, at the end of the day, your health and your wellness and the probability of you slipping from design to dysfunction to disease is based on the health of your cells. I think that's a simple concept that most people can understand. But many episodes ago, I talked about how we are simply a collection of cells, and cells group together to make up tissues that we find in different organs and glands. And then organs and glands are organized into systems that all talk to each other to create function. So ultimately, your functional capacity and therefore your quality of life and your risk of dysfunction and disease actually starts at the cellular level. So then the question becomes, what do your cells need to be healthy and to function well? Since the cell is the most fundamental part of who you are and how your body works, and cellular health is the basis of whole body health, this is the most logical place for us to start. Yet it's skipped by so many people. So here goes. There are many different ways that we can slice and dice this, but I think this is the most effective way to look at it. First of all, cells cannot perform any function without a source of energy. And obviously different cells do different things, but none of them can do anything if they don't have fuel or energy to do so. In fact, many major metabolic problems like insulin resistance or diabetes, even dementia, can be boiled down to poor cellular energy control. So if a cell needs energy to function properly, clearly energy supply is a critical factor in both cellular and whole body health. And this has implications for large things like your diet, for example, how many calories you eat, if you can efficiently burn fats and or carbohydrates as a fuel source, or even to get more technical, the number of mitochondria that you have. And we'll talk more about that later. But let's assume for the moment that your mitochondrial density is fine. Let's assume that your diet is decent and that you can easily burn fats or carbohydrates for energy, assuming you can get those fuel sources from your mouth down to your cells. But what if you can't? Right? So to get fuel from your diet into your cells, and the fuel comes in the form predominantly of fat and carbohydrates, in order to get the fuel from your diet into your cells, you need one main thing, and that is good blood flow. And that means a few things need to be in place as part of how you need or how you can transport nutrients into your cells. Now, let me back up 1 second. Why am I saying that you need one main thing to get source of energy in your diet from your mouth to your cells? Well, you eat food, you digest that food, and the resulting amino acids, essential fatty acids, and glucose that comes from them, these are your fuel sources. They have to go from your gut into your bloodstream to your cells. So you need good blood flow. And so again, this means that you need a few things to be in place as part of how you transport nutrients into your cells. Number one, you need enough red blood cells that contain enough hemoglobin, which carries oxygen, so that you can bring oxygen to all of your tissues and therefore to all of your cells. So number one, you need a lot of red blood cells. You need enough hemoglobin. You also need good blood pressure, enough to perfuse your tissues with all of the nutrients and the other goodies that are contained in your blood, because your blood is a delivery system. Now, let me add one more thing to this hierarchy. And this might get a little bit complicated, but I'll simplify it as best as I can. Your body has two main energy producing systems inside your cells. One of them burns glucose from carbohydrates, and the other burns glucose, essential fats from fats, as well as ketones, if they're available, with the help of oxygen. The one that burns glucose does not use oxygen. The one that uses oxygen, we call this oxidative phosphorylation. And I might use that term a few times as we go through the next handful of episodes. Now, this is part of the whole aerobic or anaerobic metabolism that you may have heard of before. For example, when you're doing aerobics, you're exercising at a certain pace and intensity and duration so that you're using the energy systems that actually can burn both fats and carbohydrates efficiently, but you're doing it in the presence of oxygen. When you're doing anaerobic exercise, I'm kind of getting a little bit ahead of myself, but I think it's important to know. Anaerobic exercise is basically exercise that burns glucose as the primary fuel source to provide quick, powerful energy, but does not require oxygen. So oxygen plays a really critical role. The difference between the two, the difference between aerobic and anaerobic metabolism or energy production, is that the energy system that makes the highest amount of energy for your cells to use is the one that uses oxygen. It's the one that again, we call it oxidative phosphorylation. And what that means then, pardon me, is that we have to fold in heart and lung health. Both are critical to overall cellular health because it deals with how you take up oxygen from the atmosphere and the air that you breathe. Your lungs need to be able to take in a certain amount of oxygen, which gets added to the hemoglobin of your red blood cells, so the red blood cells can ferry that oxygen to your cells through your bloodstream. And you also need adequate blood pressure to make sure that your blood, which contains potential fuel from fatty acids or glucose or ketones, plus the oxygen from your red blood cells, you need enough blood pressure so that your red blood cells and all these goodies get squeezed into all of the tissues so that your cells have what they need to make the energy that serves their function. In other words, assuming your diet and things like gut absorption is proper, at least reasonable, anything that interferes with blood flow and the delivery of oxygen and fuel sources to your cells will compromise cellular function, which will affect the functionality of all of your cells, all of your tissues, all of your glands, your organs, and the systems that they make up. And these are the things that drive and determine your health and your functional capacity. So in practical terms, that means you can't have any of the following and ignore them, because if you do, things are not going to get better. And this is where we start to build the actual elements of this functional hierarchy. Number one, it's about blood flow and delivery of oxygen and fuel sources to your cells, right? So number one, you can't have low blood pressure. If your blood pressure is less than 110/70, this is not good. Since there is not enough pressure in the system to squeeze your blood and what's in the blood into your tissues, to your cells, to the extent that you should. And the result typically are things like fatigue, cold intolerance, or being cold all the time, especially hands and feet. And it can affect how your brain works. It can promote things like brain fog, but certainly brain fatigability. Like you can use your brain for a while and then it just stops because your brain gets tired. So number one, you can't have low blood pressure. Number two, you can't have any form of anemia, whether that's related to low iron, which is best measured on lab tests with something called ferritin, not the serum iron, but the ferritin. You can't have low B12 because iron deficiency anemia and B12 anemia are the two most common anemias that we see. You also can't be systemically inflamed. That can cause a non-nutrient type of anemia that we see quite often, because all of these forms of anemia, it doesn't matter how we get there, but once we have reduced red blood cell counts or hemoglobin, we reduce our capacity to bind oxygen and bring it from the lungs into your cellular environment. You need enough oxygen to your cells to make energy. And finally, your heart and your lungs have to be healthy enough, again, to take in enough oxygen, but also to remove enough carbon dioxide so that your cells can literally breathe. They breathe just like you do. It's called cellular respiration, where they take in and use oxygen and fuel sources to create energy, and the output is carbon dioxide, one of the outputs. Now, this cardiorespiratory fitness is measured by something called your VO2 max. That's the volume, the maximum amount or volume of oxygen that you can take up while you're performing physical activities. Now, again, more on that later, but this relates to your cardiorespiratory capacity. So right there, I've given you several key aspects of your functional hierarchy to check yourself with to see if you're overlooking what we call deal breakers. These are things that need to be fixed first before anything else can be expected to improve. So let me just recap very quickly, and we'll end on a short note. Number one, the functional hierarchy is about the importance of certain physiological functions that need to be found and fixed first if they're there. If you don't start with the foundation, it's going to be very difficult to build your roof and to have it stay where it needs to be. You need the foundation before you need anything else. That foundation begins with the delivery of critical nutrients for cellular function. They would be things like oxygen and some kind of fuel source, whether that is carbohydrates that turn into glucose, fats that turn into essential fatty acids. Yes, you can use amino acids from protein as fuel as well, but predominantly we're running carbohydrate and or fat-based energy systems, and we need a delivery system. We need enough blood pressure to be able to get the nutrients that are in the blood that we take in either by breathing or by consuming food. And we have to have enough pressure to push all of that stuff into your tissues all the way down to the cellular level so your cells can then burn fuel sources in the presence of oxygen to give you high yield energy to serve functionality. All right, we're going to leave it there, and we'll be back again with the Inflammation Nation. We'll talk about the second part of the functional hierarchy, and you'll have to come back to see what that is. Take care, guys. We'll see you soon.